Problem 7. Consider a coordinate plane with points A at -5, 0 and B 5, 0. For how many points x in the plane is it true that xa and xb are both positive integer distances, each less than or equal to 10? And so, as with all geometry problems, the very first thing you should do is draw a diagram. So here's A, and then here's B. And just to be clear, x can be any point. There's a lot of choices for x. And so yeah, now let's consider some stuff. So let's just interpret our conditions first before we try and count. So firstly, we have that xa and xb are both positive integer distances, and they're each less than or equal to 10. So xa and xb are less than or equal to 10 and greater than or equal to 1. Those are the bounds we have. Alternatively, xa and xb are like chosen from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And next, we also have that if we have point x here, we actually know something about x. There's a little thing called the triangle inequality. And this tells us that xa plus xb is greater than or equal to ab. Because the shortest distance between any 2 points, AB, is the straight line, AB. And so this thing has to be true. But also we know the value of AB is equal to 10. So we have that XA plus XB is greater than or equal to 10. And so the goal here actually is, since there's infinitely many choices for X, we can't really like test all the values of X, but what we can do is notice that there's not that many choices for the values of XA and XB, and we can try and use the values of XA and XB to determine where X is. And so now we have XA plus XB is greater than or equal to 10. We can break this down into two cases. Case 1, XA plus XB is equal to 10. And in this case, this means that X lies on the line AB. This is the only way that this can happen. It's the only way, because when X is here, AX plus XB clearly equals AB. And so how many choices do we have for X here? Well, X has to be, because of these bounds, X has to be somewhere along here, and X can be from -4 to 4. So this case has 9 choices. What about in case 2, where XA plus XB is greater than 10? Then now we can first notice that for these values of XA and XB, we would have that X isn't actually uniquely defined. If we have another point over here, call it Y, and we reflect X over AB, we have that AY equals AX and BY equals BX. So for any pair of values, AX and XB, there's actually a pair of value. There's actually a pair of points, there's a pair of points, X and Y, both of which satisfy the values XA and XB. So we'll have 2 times over here because there's 2 choices for each value of X for each pair XA, XB. And so now let's try and find the number of pairs XA, XB. So what if XA equals 1? Well then, or for XA, you have XA, actually I'll start from the top. If XA equals 10, then XB can be any value between 1 and 10. So this gives you 10 choices. there's 10 choices. What if XA equals 9? Well, then XB has to be between 2 and 10, because if XB equals 1, then XA plus XB equals 10, and that's not greater than 10. So we have 9 choices, and then this continues all the way down, actually all the way down to XA equals 1, at which point you have 1 choice. So then total number of pairs is 2 times the sum from 1 to 10. So there's 55, so equals 1 to 10. So basically there's 55 possible pairs of XA, XB, for which XA plus XB is less than or equal to, is like where they're integers between 1 and 10, and XA plus XB is greater than or equal to 11. It's 55 choices. Multiply that by 2 because each pair of these values determines another pair of points. And so we have 110 and 9 choices. Adding them up, we have a total of 119 choices. And so yeah, we're done with this problem.